Mirai is a type of malware that automatically finds IoT devices to infect and conscripts them into a botnet, a group of computing devices that can be centrally controlled. The rise of Internet of Things malware is reminiscent of the viruses, worms, and intense email spam that plagued early Internet users. Most PCs were not adequately secured, and companies racing to join the dot-com bubble didn't necessarily understand the importance of Internet security. The same is true now, but with webcams and routers instead of desktops. What is distinctly different in this tech generation, though, is how users interact with infected devices. An infected desktop PC often malfunctions, slows down, or notifies users, either through operating system security alerts or through the malware itself in the case of something like ransomware. All of this encourages people to act. It is a standard practice to install some sort of security software on enterprise PC, and antivirus measures are popular at home as well. IoT devices like routers, though, are workhorses that are meant to function indefinitely with minimal direct user interaction. One reason Mirai is so difficult to contain is that it lurks on devices and generally doesn't noticeably affect their performance. There's no reason the average user would ever think that their webcam, or more likely a small business, is potentially part of an active botnet. And even if it were, there's not much they could do about it, having no direct way to interface with the infected products. From the Internet of Botnets, this IoT army can be used to mount distributed denial of services DDoS attacks, in which a fire hose of junk traffic floods target servers with malicious traffic. These attacks have been enabled both by the massive army of modems and webcams under Mirai's control, and the fact that a hacker known as Anna Sapei elected to open source its code in September. While there's nothing particularly novel about Mirai software, it has proven itself to be remarkably flexible and adaptable. As a result, hackers can develop different strains of Mirai that can take over new vulnerable IoT devices and increase the population and compute power Mirai botnets can draw on. In August, the IoT-fueled Mirai botnet appeared and amplified the seriousness of DDoS attacks, making them more malicious, widespread, and harder to stop. 2016 will serve as a watershed moment in cybersecurity. So what does 2017 have in store for us? To find out the latest in DDoS trends and gain insight into the attack landscape, the massive scale of recent DDoS, distributed denial of services attacks, in October 2016 on DYN servers that brought down many popular online services, include PayPal, Twitter, Reddit, GitHub, Amazon, Netflix, Spotify, and RuneScape in the US, gives us just a glimpse of what is possible when attackers are able to leverage up to 150,000 unsecure IoT devices as malicious endpoints. Key findings. The DYN servers attack has been analyzed as a complex and sophisticated attack using maliciously targeted, masked TCP and UDP traffic over port 53. DYN confirms Mirai botnet as a primary source of malicious attack traffic. The Mirai botnet is a network of devices infected with self-propagating malware. Unlike other botnets, which are typically made up of computers, Mirai targets IoT devices like routers, DVRs, and web enabled security cameras, enslaving vast numbers of these devices into a botnet, which is then used to conduct DDoS attacks. Attack generated compounding recursive DNS retry traffic, further exacerbating its impact. During a DDoS, which uses the DNS protocol, it can be difficult to distinguish legitimate traffic from attack traffic. For example, the impact of the attack generated a storm of legitimate retry activity as recursive servers attempted to refresh their caches, creating 10 to 20 times normal traffic volume across a large number of IP addresses. When DNS traffic congestion occurs, legitimate retries can further contribute to traffic volume. We saw both attack and the legitimate traffic coming from millions of IPs across all geographies. It appears the malicious attacks were sourced from at least one botnet, which the retry storm providing a false indicator of a significantly larger set of endpoints than we now know it to be. We're still working on analyzing the data, but the estimate at the time of this report is up to 100,000 malicious endpoints. We're able to confirm that a significant volume of attack traffic originated from Mirai-based botnets. Attack is likely tied to an amateur hacking forum community, which is neither state-sponsored nor financially motivated. This attack has raised significant concerns over the cybersecurity of IoT devices since their insecurity problem was exploited on this significant scale by a non-state group. Imagine what a well-resourced state actor could do with insecure IoT devices.